Everybody, Scout Crafty here again. It's Monday, Mishmash Monday. We have a couple things to talk about today. Had a little rain this weekend. Hope you had a great weekend. Today is Columbus Day. What we have now is we're going to start off with part 2, finishing up that $10 Baldor Kalamazoo grinder I got. Let me show you what I'm talking about. Okay, for those of you just tuning in, didn't see part 1, I bought this Kalamazoo, this beautiful Kalamazoo belt sander for $10 as is at a Zagre. It was a machinery show over in Connecticut, and it was a great deal. The problem was that it was missing the wheel, the drive wheel for the belt sander. It had a spacer on for the middle of it, but the rest of it was gone. So I wanted to replace it with one. The problem is that they sell them at Kalamazoo, but they're $50, which is, you know, a little bit steep for considering what it is. So I'm going to try and do it with without spending the $50 and get the same results. Let me show you what I did. I went on Amazon and I looked for anything that was approximately 4 inches in diameter wheels and anything that was about a little over an inch wide, and I came up with these two. These were about $5 each, believe it or not. Now, this is the one that's very similar to the one they sell. It looks almost identical to what they sell. And but I like this one. This one here has a nice look to it. I like this one. I don't know what material that is. Again, they're made as being casters for wheels for equipment, so they're very strong. You know, and you don't have a lot of pressure on them belts. But the thing is that they come with bearings, okay? This is a problem. You know, if I was trying to find one, any kind without a bearing, just a straight hole. They don't make them. But that's no problem because we have a lathe. We can have some fun and figure this out. So let's try this one first. Now, the first thing we want to do is we got to pull these bearings out of there because obviously it's a drive wheel. We can't have this free spinning. Now, you see here, these bearings, there's different ways that bearings are placed into items. They're either pressed in a lot of times. Sometimes the item is actually heated up to expand it, and they put the bearing in a freezer to contract it because cold contracts, heat expands, and then they just slip it in, and then when the two temperatures normalize, that bearing is in there and it's not coming out. There's a whole different, you know, bearings are really interesting when you think about taking them in, putting them out. However, with this one here, because of this material, I'm sure they didn't heat it up. They're just pressed in lightly because there's really not much pressure and forces to pull them out. So what we're going to do here now, this is what would be considered almost like a blind bearing to try and get this out. You would have to take something that goes in that hole, expands, and pulls it out. You know, otherwise, if it was just one bearing, you could press it out with the dake. So what we're going to do here is we're going to try and take a punch and tap out the bearing from the other side. Now, it's usually not a good idea to tap on any type of bearing surface, but again, we're not reusing these bearings. You know, we just want to get them out of here, and I'll show you what we're going to do. Okay, now this is why the vise truly is the most versatile piece of equipment you have in your shop. It's if I had to pick one tool, this would be it. This is the only. Now, what we're going to do is we're going to want to put the vise a little bit wider than the bearing surface, the size of the bearing. Over here, we'll just close it up a little bit like this, just about like that. Now we're going to place this over here. We're going to tap out the bottom. But before we do, we're going to cover, not to protect the vise, because this obviously won't hurt the vise, but we're going to cover this with a little bit of tape, not to mar or damage the surface of the wheel. Now, believe it or not, small pieces of tape like this really does make a difference in just stopping any kind of indentations on the wheel. And also, even if you want to make you put it on the face of the jaw, tape is great for stopping a lot of the knurling of the jaw to mess up your surface. So now what we're going to do is we're going to take this punch here and we're going to place it. It's magnetized, as you can see. A lot of times that happens. We're going to take this punch here and we're going to tap it at a slight angle all the way around here. And again, like I said, because of this material, I'm sure it wasn't pressed in with any force. It should come out quite easily. So we're going to tap that easily with a light hammer. Now for the hammer for this job, we're going to use this, remember this custom hammer? The one that has a grip that's exactly to my hand. This thing is fantastic. Anyway, we're going to pop this now. Now, just light taps around the top on each side, going back and forth. And then take a look at it. Look at that. See what I'm saying? It's, you know, there's no way that this, because of this material, there's no way they're going to use extreme force to press these in. So see how easy that's coming out. And we're going to just keep doing that until that bearing pops out. It's light taps going all the way around, different angles. And eventually, there it is. It popped right out. You could see. I didn't even hear it. It hit the, there we go. There's our bearing. Undamaged. Now, you see here, the reason we didn't try and press it through the bearing is because that's called a bearing stop ledge. See that ledge in there? That stops the bearing, so that's, you know, they press it until it hits that. That's good, though, but that's no problem for what we're going to use this for. Now, to do the other side, it's a lot easier now because we have a full view from this side. You can see 1, 2, 3. Both bearings are out. Now we have a wheel that we can make a hub. Here is the original hub from the other drive wheel. This is the original Kalamazoo, and you can see it's very close. This is almost identical to what we're using. So now all we have to do is we have to clear this out, any ridges in there. We'll get rid of that bearing stop ledge in there. It's on both sides. We're going to put this on the lathe. We're going to get rid of that, and then we're going to press in a new hub. And Bob's your uncle. That's all we have to do. Now, we can make the hub out of anything we want. I'm thinking maybe Delrin, because Delrin's just too much fun to work with, and let's have some fun. Believe it or not, this is where the challenge of this project comes in. Now, like I said, we have to get rid of this this burring, or that's all around on the inside of the wheel here. And how are we going to do that? Now, how are we going to mount this into the lathe? Now, because this was, you know, you can see there's a seam here, and because this was, you know, probably some kind of a liquid or plastic or something that was formed, these are not straight up and down, all these ledges here. And the reason is so that they can release from the mold. Okay, so this here has an angle going this way. This one here has a slight angle going this way. So you can't get, even your lathe jaws wouldn't be enough to fit in here and hold it. So it's, you know, the only way you can hold it is to grip it from the inside and do half, cut half, and then flip it and cut the other half, because this is the only straight area, you know, that's perpendicular to what's going to be the outside. Now, another interesting thing about wheels, especially drive wheels for sanders, if you notice, the top here has a conical edge on it. You know, it's not straight across like that. It has a dome to it. And the reason that these are convex or conical in shape is because the belts always want to ride to the top of the dome here. So if you have a flat belt, you're always going to have a flat wheel. You're always going to have tracking problems. The belt's going to always go back and forth. So you want to put a slight dome on so that the belt is always self-centering. Okay, we're at the lathe here. And now if you notice the jaws in the chuck, these are very interesting because they're made to grip. Most things that you grip in the jaws are going to be gripped like this here. You see, you're gripping it and you're holding it. But they also have steps on the outside, you could see, that's also meant to grip things that you can expand the jaw out to grip something that's round. And that's exactly what we're going to do with this wheel here. So we're going to bring the jaws all the way in like this. We're going to put the wheel here, and then we're going to bring the jaws out, expand them out into that edge, and that will hold it. And then we'll see how it's running, if it's running true or not. And you can see there's just a little bit of a wobble. Now we'll tap on one side until we get that as straight as we can, because remember, you know, once we get this done, there's no going back. Okay, now we have this running as true as we're going to get it on here, because like I said, it's not made for precision, but let me show you what it looks like. That's more than true enough that what we need for a belt sander, because we are going to true it up a little. Now what we're going to do is we're going to bore into here. It doesn't matter what size, because we're going to make the bushing to fit here. So we're just going to clean it up. Again, it doesn't matter what size. Okay, now what we're going to use is something called a boring bar. And they call it that because these really aren't too exciting to use. Actually, it's meant to bore a hole in here, and I'm going to show you how this works, because we're going to go in for, I'm going to bring you around, and this is really good to enlarge or true out a hole. Okay, here's the setup, and you can see, like I said, we'll get it to this point. You could bring it right here just to touch it, back off a little bit, and then work your way in, and then as you draw the tool this way, it'll make cuts. Very interesting. Okay, that worked out as we expected, beautifully. Now what we're going to do is we're going to face off this little area here, because it'll line up much better when we flip this around, because there might be some imperfections on this outer lip, and we're going to change that. So we're just going to change the tools over here, okay? And what we're going to do is, I'll show you this in real time. We're just going to face off this little area right here. There we go. Now we know that that's flat according to the bore that we made. Okay, now what we're going to do is we're going to flip the wheel around, and when we do, when we flip this wheel around, it should, because this is nice and flat now, it should go up flat against the jaws, and when we open it up like this, it should run true right off the bat. And there we go. Okay, now we're also going to face off just this side, so that if we do put on any wash or anything, that it's going to be square to that. Okay, so here we finished cleaning out the inside. You can see it's straight, it's true. Now all we got to do is make some kind of bushing to act as an interface between this and the motor. Now we don't want that to spin inside there, so we're probably going to add some kind of an adhesive or a way to lock it in so it can't spin. Again, there's no resistance really on a belt. But I was thinking we're going to use Delrin. Why? Because I love working with Delrin. There's so many things we could do with it, and I happened to buy a lot of it on eBay a while ago, so why not use what you have? Okay, these are the outside jaws installed, and you can see they don't have the outside ridges over here. They're meant to grip larger items, so I can open this up, and you can see I could grip a much larger item. I can even grip an even larger one out here. But now, you can see this is saw cut. You see the lines in there? That is saw cut. Now, that means it's not going to be super true. This one here, however, because it's got, this one here looks much like a lathe cut. So that's what we want to do. We want to do that on this side. So we're going to put this side here, and we're going to see how it runs. It should run very true, because that looks like a lathe cut side. I'm going to turn it on. And you can see that runs nice and true. So now we're going to face off this side, flip it around, and that's when we're going to do our work. Now, we want a slip fit. You know, there's a press fit where we could press it in with the dake, but we're going to use a little bit of an epoxy to make sure that that bushing doesn't spin or move in there. So we don't want a press fit, because that'll press out all the epoxy. We want a snug fit, but not quite, you know, a press fit. So let me face off this. I'm going to show you some old-timey tools that really do come in handy. These are called outside calipers, because they grip the outside of something, and those are inside calipers. And how you use these is we adjusted these so they just slip over the shaft, okay? Because that's the, remember, we're going to slip that bushing over the shaft, so it just slips over the shaft, right? And then what we do is we adjust the inside calipers to the exact same. You see that, how it just slips over? And that's how we're going to measure the hole for the bushing. Okay, now we cut the 1/2-inch inner diameter bushing hole in there. Now we just have to size this to a slip fit for the bushing, and then we'll press it in. Now remember, we said the inside calipers works the same way. Now if we wanted to get this inside of this pulley if we wanted to get that, or the drive wheel, we can just open this up until it just barely touches, okay? And it's just barely touching in there. And then we take that out, and we can open up our, you can see here, we can open up our, these are our outside calipers, and open them up until it gets to the same size, you see? And when it does, right there, that's how we'll know we've taken it down enough when we're working on the lathe. Now we have this supported on this side because anytime you have a long overhang outside the jaws, you want extra rigidity. So we just put this over here. This is a bearing that will spin with that hole. And again, we only need a bushing to be about this long, but we're going to take it down a little bit further and then cut off any excess we might deem that we need. So let's get to that. Okay, now we are down to the point. You see that? See how that's fitting on there? Just grabbing. Now, watch this. We'll take the wheel here just for a test fit. Now you can see I can get it on. And again, we're going to be using epoxy on here, but you can't have it too tight because the epoxy will push out, you know. And then, you know, but you can see here, we got a nice fit on here. See, I'm pushing this on, and we'll see what it looks like. Look at that. There we go. So now all we got to do is cut it, squeeze it in with a little epoxy, and then we should have a drive belt. Now I decided to put little grooves in here, just slight little ones, to hold any epoxy and act as grippers, more or less. So let's do that. Okay, we are calling this one almost done. Now you can see here, you could have taken using the outside part of the inside caliper here, and you can see we have 15,000. You could see here, and then you transfer that over to the outside of this. Okay, and you could see we have 14. So we have that clearance fit that we wanted. Those are the ridges we put in there to hold whatever we're going to use, probably a slow set epoxy. Now, if I push this in, it only goes about halfway before kind of getting stuck here. But I will, coat this with epoxy, then, either tap it down or squeeze it down in the vise, whatever. But it will go in, and then we'll mount it onto the machine. But that's what we made today, similar to this. What a fun project this was. Okay, now I wiped the bushing and the inside of the drive wheel with denatured alcohol, and I let that dry, and then I epoxied it in. But it, like I said, it was a great fit. Just tapped it in. We have it in. It looks nice. Now we'll wait till it dries and then mount it onto the machine. Okay, it's been 24 hours. You can see the epoxy is now hard and dry. What we're going to do is we're going to take the wheel that we have here. I made this almost this very snug fit, you can see, because you don't want that rattling around on the shaft. So we're going to have to just use a little bit of force to push this on, and then we'll put the nut on here and get this going. Okay, let's see how this works. Look at that. Nice and smooth. Now let's put a belt on. This is the 1x42 belts. You can buy them in an assortment of different grits. Here we have a basic assortment. Comes with some coarse and fine belts. We'll just put belt sanders. This is your tracking knob right here. You see this knob right here? That's your tracking. And how that works is you turn it, you just give it a spin like this, and you track it so that it runs in the middle of the belt, of the pulley, like there. And when you get it where it's running in the middle, then you just tighten this down, close the cover, and you're good to go. Okay, here we go. You see it's tracking nice on the pulley, on the bottom, tracking nice on top here. And it's a beautiful little unit. Okay, let's try this out. Now, it's funny because the motor is much quieter, but This little guard up here tends to always, you know, or anytime you have a guard on there, they tend to make a little bit of noise, but it's much quieter than the brush motor. So there we have a 1x42 Kalamazoo fix or repair. You know, saved about $60 on this repair, but, you know, that's why they say if you have a lathe long enough, it eventually pays for itself, and it really does. You know, certain tools just come in, they're invaluable for certain operations. You know, this is a hard job to do with regular hand tools or even a drill press or something. This is something where the lathe really shines. So anyway, I hope you enjoyed this little couple episodes, and take care. I hope you have a great day. Bye-bye now.